Alright, so I hope that I am audible also, and as well as my screen is visible to everyone. Alright, welcome back. So this is live session 3 on real world project. This skills is very important, and it should be going to be very important uh, in 2025, especially for senior folks who are having uh, 10, 15 years of experience and trying to move from other domain to AI/ML domain or Gen AI domain. So please follow regularly as much as you can, and I also try to be regular. I believe that uh, making 1.5 hour is little bit difficult, so I will try to make at least um, 45 minutes to 60 minutes maximum every day. Alright, so that regularity should be maintained. Alright, so today I will try to understand or explain you part 3, which is our phase 3 task, which is basically a performance optimization, right? This one. And I will prefer to make things little easy or simple for everyone. So maybe I will read out some of part, and then at the end of this session or if the project has progress, we will try to share this document, final document also, so that you will get the. And by the way, at the end of this, I will share GitHub repository where you will find everything related to the project code, readme files, this design doc files, and requirement detail, how I have analyzed it, and what kind of tech stack is used, and how to run this uh, uh, service, or how to run this developed MVP. Uh, I would not say the MVP because it is going to become a production ready service or solution, right? So it is a solution which is production ready, and you can release it also if you are really following regularly, right? And making the things as we progress. And whatever the suggestion, whatever the code we are doing it, please follow. You will find that your solution would be uh, almost production ready, right? Only thing is after that, when you release it, you will need to maintain operation, and some cost is related to operation also. You have to be for that, right? All right, gentlemen. So because as I mentioned already that we are going to use Gro Cloud for inferencing, so uh, definitely it has a inference cost, and latency is our parameter to look at, right? So evaluate um, AWS, I would say this one, to connect and secure high speed link if large volume of data uh, must travel to Gro Cloud, right? So we'll try to uh, how we can secure, or how we can connect your AWS cloud and Gro Cloud. Direct connect would definitely require some costly affair over there. So we will try to see that how much performance improvement going to happen due to direct connect. So those kind of evaluation we have to do it before, or we have to so evaluate as per the performance metrics, performance metrics and cost. All right. Now consider caching frequently asked question in Redis to reduce repeated calls. Yes. So this is very, I think it is very understandable that you should avoid the repeated calls. If something is cacheable, cache it, right? If something is uh, to be possibly to be cached, then cache it as per the requirement, right? Cache it as per need and feasibility. Of course, if some data which is very dynamic in nature, then we should not cost, because it anyway going to change every small time interval, so you don't require to cache it. Don't waste your memory in that case, right? Cache memory in that case, right? Next is how to uh, how to do the model compression, because uh, if partial hosting or edge hosting is needed, check if Gro Cloud or DeepSeek R1 support distillation or small variants, right? So that thing you have to also discuss with Gro Cloud as per your requirement. But this is probably the later task when you will go to the production mode, not right now, because the in building maybe. But this point consider and noted. I mean, since you have noted it, you probably have to execute some analysis over it, right? So that's why it is important to note down, but some task may be later also. So later task. All right. Now go to enhanced evaluation. What does it mean? Under this enhanced evaluation, you have to check that, like evaluation. Evaluation is basically checking the metrics. So some semantic metrics, maybe operational metrics. In semantic metrics, we will use BERT score or similar metrics, real user queries, right? So you can, I mean, you must evaluate the how semantic metrics are performing, right? What kind of report we are getting. Then we also have to check operation metrics, because we have a different AWS component which is not indirectly controlled and which is not cost free. So that's why we must have to evaluate it properly, and also try to check that actual cost, right? Because otherwise it will definitely give you lots of so check actual cost is important here, right? Now, so at the end, let me iterate the key AWS services which we are going to use here, right? Okay, so what is that? Let me read out for you. So the first point is compute EC2 GPU instances, ECS, for custom embedding model, right? All right, so this is one thing, compute EC2 with GPU instance, right? This is required. Then networking part is like AWS Direct Connect, or I mean, if it is required, I am not sure, but if it is required. Then CloudWatch metrics, custom logs, etc. All right, let's go to the next slide. And here in phase 4, now until this point, you are very much developed the basic model, basic MVP model, and now your time to think about scalability and improvement. If any thing which is coming in report and which need to be improvement, then this is the time to think about that part, scalability and improvement, right? So this is my fourth part, is scalability and improvement. All right, so let's do it now. The first point is multi-tenant and multi-use case. All right, so like microservices, try to use Amazon EKS or ECS for separate departmental services, right? So uh, try to think about the microservices architecture and try to break down each separate work into a different services, into a separate services, and create a microservice service architecture as per your division, right? Then this is one thing, if it is a microservice. Anyway, I mean, that is the service part. Then we have to build some API, I mean, centralized API gateway, use some centralized API gateway so that your client application can use it, or anybody who wants API over it. Because if you remember, I told you that we are going to launch this as a software as a service, right? So if they are using dashboard, then of course they are going to consume our API, that dashboard. You do not need to directly expose, but since I am allowing them also to tweak or use or create their own application which will consume these API and use these features. So that's why both are creating is or creating a business model for us. So that's why we will go. One thing is that through our own dashboard we will allow to use this, or otherwise if they want to create their own app they can do it, right? Then for monitoring analytics, we can use our like Amazon Open Search Services, which is for deeper log analysis, because many time distributed system has one core issue is to, because of abstraction, it is sometimes very difficult to track down the issues, and in that time basically a log is one of our friend who is giving us that what would be a possible probable cause for it, right? Then log aggregation is there, right? Log aggregation is there. Then BI integration. So Amazon QuickSight or external solution like Tableau or Power BI for matrix dashboard, right? All right. Now, third is ongoing maintenance. So we have to think about AWS code pipeline or code deploy for kind of CI/CD features if you want. Since while doing it, I always believe that we should follow the standard architecture or standard concept which is available, even though it is a paid one, because every paid one there is some workaround. But in initial time we should not think about the workaround. We will replace these costlier service one by one later, once it is mature, once your MVP is mature. And please note that being a developer you have to understand that once your MVP is getting maturity or client attention, then you plan for cost optimization. Then you plan for cost optimization, right? Don't start in initially, because if you start from scratch, from beginning, probably your focus would go on that side, which is really difficult to manage so many things, right? Then uh, see, model sometime, if you have a model, just like if Grok Cloud is allowing us to fine tune uh, DeepSeek R1 model, if they are allowing, or if they are giving some kind of uh, feature of some sort of that, then this would be our task. But it depends on definitely a Grok Cloud. So just check that does Grok Cloud is giving this or not. If Grok Cloud is allowing it, then only you can do it. If Grok Cloud is allowing is allowing, so we'll check that does they are allowing or not. Then another thing which is very important, which is security audits, because I will tell you that in cloud or cloud environment especially, trust is a really very at kind of at the boundary between the service provider and client. Client never going to easily understand or easily assume that their security is at safe place. So especially for so many threats is going on, or digital data is so much data is generating. In that scenario, definitely it is really very easy to I mean create or observe as a distressful to with the service provider. That's why this factor definitely require very good attention as a developer and architect. In this phase, so primarily we will try to use orchestration, EKS or ECS, then analytics, Amazon QuickSight, and Amazon OpenSearch for such kind of things. Then DevOps is code pipeline, code build, and code deploy, and security is AWS security hubs. So I think these 4 services we will try to use here, which is useful for to execute this phase organized way, right? Let's move on, and I hope that this is basically what are the part of component we are going to build. So we have as I mentioned here, that we have a web client, then through the API gateway, chatbot API is there, which is kind of lambda function, and this will finally call ECS or ECR images and do the then this will basically do some similarity search over the vector DB, which is in our case it is elastic cache, and as soon as we get the context, right, then we will pass this information to the Grok Cloud, right? And then we are assuming that this Grok Cloud will return the response to us. So we will explain one by one these all components. Again, we'll come back on this this slide. But for now, let's move on, because that is what we are going to discuss. All these components going to discuss, right? Now, so I think this is, you have to read it. Most of the things we already discussed. So I will move from here quickly. Then, okay, and try to check the feasibility, potential gaps, and next step is something which we are going to discuss later. Okay. Now let's do the technical feasibility analysis first. Okay. So when I did this analysis, right? When I did it, I will just try to get the, I mean, result in this way, which I create. I mean, this noted down here in this table. One component which is DeepSeek R1, as I mentioned, and feasibility assessment. When I did it, I realized that Grok's LPU offer ultra low latency, potentially less than 50 millisecond. So that's why it is more suitable, even better than OpenAI or any commercialized, or I mean any other service, inference service API, which is available in the market, right? Use AWS private link or direct connect. So because there is a because of this requirement of ultra low latency, and since we are going now via through the AWS cloud to get the, to create the service, what I feel that we have to create some AWS private link or direct connect for secure and low latency connectivity between AWS cloud and Gro cloud, right? So we will definitely work on this area to check how much feasibility and how much possibility of this kind of things. I believe that this is possible, but then yes, Gro cloud is not a traditionally cloud and a service provider or a service API kind of thing. So we have to check once, but I believe that this is feasible or possible, right? Then cache frequent queries in Redis to reduce repetitive Grok API call. I think it is already discussed earlier also. Then AWS compute, in this case we use Lambda in phase 1, and then later we will try to use the ECS or AKS needed for advanced or GPU configuration. All right. So these things like that, DeepSeek RQ, AWS compute, then vector DB, and then vector DB for similarity search. For vector DB, we can use Amazon Elastic Cache, and can do the vector search. So, and if we will see any issue in this, then we will go to the Pinecone instead of AWS, because Pinecone is a more optimal solution because of indexing and all, lot many things. Even that is possible in AWS Elastic Cache, but we'll see it. I'm not sure. Okay. All right. Let's move on. Then data engineering part. So in our case, like enterprise data must be stored, their embeddings must be stored inside the vector DB. So we have some kind of event handling in S3 repository, S3 storage, where if you upload any new file, it will trigger the event, and our job is to launch the Lambda function based on that trigger, event trigger, and then you will proceed whatever you want to do as a, create embeddings of a document and then upload it to Amazon Elastic Cache, right? That is what we supposed to do, right? This is what embedding pipeline is all about. Okay, real-time ingestion. So S3 plus Lambda works well for batch but lacks streaming. So we will try to think later, but for now we will start S3 plus Lambda. If there is any problem, then we will try to use a Kinesis data stream for real-time ingestion of this, right? So we'll see. But for now, we will try to use this also, S3 and Lambda and ST event. All right, let's move on to security and compliance. So we will try to PII handling. So sending PII to Gro Cloud may raise GDPR or CCPA for data residency risk. So in that case, we will try to use AWS Comprehend or Microsoft's Presidio in Lambda ECS to impact PII before calling Gro API. Right, so I will try to use this one only, AWS Comprehend, not Microsoft Presidio, right? So that is what I am thinking, right? So I am not interested in this, I am interested in this only, okay? Evaluate if Gro can host data in compliance with your region's regulation. Yes, this is also possibly done because in some scenario, in some geography, especially in Europe, there is a very strict guideline for security. So in that case, you will definitely have to use something. But for MVP, I believe that you have only note down it. We will then analyze later, right? That's it. Now, this segment is very important, modern and agentic workflow, because this is going to create some buzz for this project. Because agentic workflow is important to optimize or to get the better ROI metrics for your organization. Because of the involvement, because of less human involvement, right? Because it will work around 24/7 by small maintenance, right? So that is what I think we will see, and all right. So let's say a strategic implementation plan. So phase one, MVP week 1 to 4. Objective: validate an end-to-end query workflow using DeepSeek R1 plus AWS. Right? So Grok integration, vector DB setup, basic UI, cost monitoring. These are the 4 segments which we need to see, and I already explained multiple times, so I can move faster. In phase 2, we will try to use agentic workflow, CRM integration, enhanced data pipeline, and security. Alright, so these things I already done, so let's move on, or I will share you share you this document so that you can go through. Then high level objectives. Alright, let's do it. So this is also like similar kind of things I have mentioned. Only thing is detailed plan is created. So yes, this is your diagram where you can mention what are the things we are going to use. Like for us, it is on the top, like UI point of view, SME dashboard. Then this SME, this one here. This is SME dashboard. This will interact with So let me put here SME dashboard. Then this will interact with API gateway. Initially, these are HTTPS, and then maybe you can use for authentication JWT auth, right? And then uh, multi-tenant orchestrator or Lambda. It depends on how you are using. If you want to ECS, that is also possible. But otherwise, if you want to use uh, Lambda, then in that case you don't need to manage the service. It is a Lambda and API gateway together give the API functionality to your dashboard. So it depends. Like initially we will start Lambda and later we will move to ECS on the top of API gateway. So API gateway and ECS is also possible. So but that is the next phase task for us. We have a vector DB where we will use elastic cache using Redis, right? Elastic cache using Redis. Okay. Then and this will basically a vector DB is populated from S3 talks, and then multi-tenant. This is finally use Gro Cloud DeepSeek. There is a one possibility. Another is local LLM Olama, right? But it depends on like local LLM, not this one. I think DeepSeek only we will try, not this one. DeepSeek R1 is only we will try. So local Olama plus DeepSeek R1. Maybe I mean we will try to see the distilled version actually, not the quantized version only possible in my opinion. So we will see. But it depends on like some analysis need to be done in there. And then agentic workflow. Third part is your agentic workflow. Okay, right? This is how we can do, right? Let's move on. So you can go for detailed component level view, but these things you will I will share this document, you can go through, right? Now let me repeat once again the key point here for you, so that you can before I start coding you can understand like what exactly we are supposed to do in this project, or what we are going to do it, so that if you want to some preparation you can do your own like hands-on things in your time zone in before joining this session, right? So we are having a infrastructure segment where we will deal with all the infrastructure related things, especially AWS, like all IAC definition, AWS CDK, Terraform or SAM, create your AWS resource. So these are infrastructure like Lambda API gateway, Redis or Pinecone, DynamoDB, etc., etc. So these are the basically an infrastructure we are currently looking for, right? Or we are building it, right? One is that. Another is agent. This is agent. Agent, a place to define an agentic or step-wise workflow. We'll see, like what should we use? Are we going to? Of course, we are using Gro Cloud this time, but what else possibility is there? We'll see, right? Then, my mistake. For agents point of view, we have a different frameworks available. Maybe LangChain, LangGraph, maybe um, atomic, right? Atomic agent, then Crew AI, then we all have, I mean, AutoGen from Microsoft, and so on and so forth. So there are possibility. We, for now, I think we will see that atomic possibility, or I would prefer atomic. But if it is difficult, then we will try to atomic or Crew AI, right? So in this case, we will try these two to analyze which one is better for us. Okay. Then lambda function, then basically chat handler is, I mean, in lambda function we will try to see that in lambda function we will try to use the chat handler, then feedback handler, and so on and so forth, right? Then there is a source folder where most of the source related things is there. So that is, then we will try to create some self-sufficient test cases also, so that at least, and then front end. All right. Um, I have created a small basic structure which you will see here. All right. But you start your own journey. Try to think on it, and then in the next video, probably I will share you the hands-on code, so that I mean you also start the coding round. Okay. And along with this live session, you will get the coding hands-on also. So in the next session, I believe we will try to cover up the coding.